This is part 284C3m1b7c8e13c9c6d3p38d19d7b9t. Line 22f1fa19c3m1b7c8e13c9c6d3p38d19d7b9t. Quantum lattice split baryon 5G Wow Seti. There's the alien radio signal. And this is splitting quarks, mesons, baryons, quantum lattice keywords PDF, file results to use with the long distance communications device from our WOW data formulas. This is March 17th, today's April 21st. This is how to split a fermion, video number 15. It's actually the 16th video. There's the line of data, quantum Monte Carlo Fermi, and lattice quantum chromodynamics technique. Keywords are splitting quarks, split fermions to bilinear form and Fermi line. And we're going to look at the keyword lattice quantum chromodynamics technique from quotes from Wiki. QCD enjoys two peculiar properties. Confinement, which means that the force between the quarks does not diminish as they are separated. Because of this, it would take an infinite amount of energy to separate two quarks. They are forever bound into hadrons such as the proton and the neutron. Although analytically unproven, confinement is widely believed to be true because it explains the consistent failure of free quark searches, and it is easy to demonstrate in lattice QCD. Assumption asymptotic freedom, which means that in very high energy reactions, quarks and gluons interact very weakly. This prediction of QCD was first discovered in the early 1970s by David Politzer and by Frank Wilczek and David Gross. For this work, they were awarded in 2004 the Nobel Prize in Physics. There's no known phase transition line separating these two properties. Confinement is dominant in low energy scales, but as energy increases, asymptotic freedom becomes dominant. Formula ideas: separate two quarks. Isolate the quarks. What's in a quark? Separate a baryon and a meson. Do this to separate the quark. So I'm going to Google separate a baryon, quote PDF files from blogs. There's the scientists. Observation of meson, central production and baryon exchange processes. Those are more scientists. The central production of PO(F2) and P3 mesons is observed for the first time in processes which are originated by pi plus P reactions proceeding via baryon exchange mechanism. The data comes from the CERN WA56 experiment designed to separate the baryon exchange reactions in pi plus P collisions at 20 GeV/C. We report on the measured integral and differential cross sections and also give the density matrix elements of the meson resonances observed. And that's link.springer.com. Next is the CDM and baryons as district fluids in a linear approximation for the growth of structure. That's the name of the scientist from the University of Louisiana, Arizona State University, that's in the U.S. February 2013, this is brand new. A single fluid approximate, well, it's kind of April, so it's fairly new. A single fluid approximation which treats perturbations in baryons and dark matter as equal has sometimes been used to calculate the growth of linear matter density perturbations in the universe. We demonstrate that properly accounting for the separate growth of baryon and dark matter fluctuations can change some predictions of structure formation in the linear domain in a way that can alter conclusions about the consistency between predictions and observations for lambda CDM models versus modified gravity scenarios. Our results may also be useful for 21 centimeter tomography constraints on alternative cosmological models for the formation of large-scale structure. And that's the link from Lawrence M. Cross, arxiv.org. Again, the keywords were baryons, fermions, and mesons and bosons from hyperphysics.phy-astr.gsu.edu. They're going to show up in the next one. How to split a fermion, video number 16. And actually, it's video number 17. Thanks for watching.